Hello everybody and welcome to this Vuex tutorial. Vuex is a state management pattern and library for Vue.js apps. By understanding Vuex and enforcing certain rules, our code will be much more structured and maintainable. You can install Vuex with your favorite package manager or with a CDN. I added it here to our dependencies on Scrimba. I'll also import it here above. Because this is a Scrimba screencast, remember that you can pause this video at any time, edit the code, and see changes in this mini browser. Feel free to pause at any time and play around during this course. At the heart of our application is the store. The store is a container that holds our application's state. Vuex stores are different from plain global objects for two reasons. One, they are reactive, meaning components will reactively and efficiently update as state changes. And two, because you cannot directly mutate the store's state. We will show you how to change state in our screencast covering mutations. Now that Vuex is installed and imported, setting up a store is super easy to do. Because we're using a modular system, we first call vue.use Vuex and create our store. To start out, I'll create our state object and include one data member, count. Next, we'll set up a mutation. We will cover mutations in depth in a future screencast. For now, it's important to remember that we do not change state directly, we use mutations. This will prevent errors and let us track all changes in our app using debugging tools. Now that our store is set up, I will commit this mutation and log count to the console so we can see if it's working. When I run our code, the store will be created and a mutation will be committed, causing count to increment. Notice how we're accessing the state object here using store.state and triggering a state change with the store.commit method. Calling this mutation runs this code here. The mutation receives state as an argument and increments count. This is how Vuex handles all changes in state within the store. And we see that it's working. Down here, we log to the console the number 1 because count starts at 0 and is incremented here. Using store state in a component simply involves returning the state within a computed property. This is because the store state is reactive. Triggering changes simply means committing mutations in component methods. This is the power of Vue and Vuex. It's highly reactive and fun to use. There's a lot more we can do with this. In the next videos, we'll be covering it all in depth so that you can use Vuex in your next great app. Hey everybody, welcome back. In this screencast, we're going to be taking a closer look at state. Remember from last time, we imported Vuex here, called it using vue.use Vuex, and set up a simple store. We named it store and used vuex.store. Within our store, we held state, which is an object containing all of our data members. I removed mutations and a few things from our app so that we can focus on state in the screencast. Vuex uses a single state tree, or a single store. Basically, this means we will only have one store and one place where we are putting our application level state. This is going to make our code much more explicit and debuggable. We won't be having to look through multiple stores or multiple components for a piece of data that we want to use. We will also have one single place where we will be having our mutations and actions and other methods to change state. So when it comes time to do debugging or testing, we'll be able to explicitly track all changes made to our data. So the next step that you might be asking is, how are we going to display state within our components? Remember, Vuex stores are reactive. They're going to be changing, and we want something that will reactively update. The best option here is a computed property. Those are set up within computed. The computed property will watch any data included in it, and when it's changed, it'll update itself based off of some function. In our case, it's just going to be returning a piece of data right here. But it could also, say, reverse a string that is put into it, format a date, whatever you might need it to do. So we're going to take a look at our HTML file. This is where our instance is located with this div ID app. And I'm rendering count. This is a property, but as you can see, if I refresh, there's nothing there because we haven't set it up. So I'm going to set up a computed property with that same name. We'll simply have count return store.state.count. And I'll refresh it again, and it shows that it's working. This computed property is returning this data right here. So whenever store.state.count changes, count will update and cause any DOM elements, like right here, to update. This pattern makes the component rely on the global store. When using a modular system, we would have to import the store and every single component that is using it. It would also require mocking when testing the component. Luckily, Vuex lets us inject the store into all child components from the root component with the store option. Right here is our root. I'm going to include the store option. It's very simple, and you might have seen something similar if, for example, you've been working with the Vue router. Now we can access the store in this component and any of our child components using this $store. In the next episode, we're going to take a closer look at mapState. This is a helper that Vuex provides to create these computed properties much more quickly.
Hey there, I'm Per, and on behalf of the entire Scrimba team, I want to say thank you for using our platform. Our goal is to help you improve your skills so that you, in turn, can improve your career. And in order to achieve that, we've created over 30 courses on various front-end development topics. Here you can see some of them, and these are all free. Actually, 90% of our courses are free. So you can learn React for free, JavaScript for free, Vue for free, and a lot of other subjects as well. However, once in a while, we launch what we call a bootcamp. A bootcamp is a massively comprehensive, in-depth course that aims to take you to a higher level in the subject that it teaches. So we have a bootcamp on responsive web design, we have a React bootcamp, and soon we're launching a Vue JS bootcamp and a UI design bootcamp as well. Now you might ask, why enroll in a bootcamp when we have all of these free courses? Well, enrolling in a bootcamp is if you want to reach a professional level in the subject that it teaches. Because these bootcamps, they are massive. They're over 10 to 15 hours of content recorded by top-notch professionals in the given field. Really world-class people that knows what it takes to take you to a professional level. And they've created tons of interactive challenges which focuses on the subjects and concepts that students really struggle to understand. So this is what separates Scrimba from other platforms. You really have to get your hands dirty with the code, and you're forced to actually learn what you need to learn. Now, the bootcamps are fully self-paced, so even though they take a lot of time, you can take them in your tempo. Once you purchase a bootcamp, you get access forever. And if you ever need help, you get exclusive access to a Slack channel where you can connect with other students, where you can ask questions, and we in Team Scrimba will be there. And also the teachers will pop in from time to time to help out. Now finally, I just want to say that this is your way of supporting Scrimba if you want to do that, because the bootcamps is how we actually survive as a company. Without them, we simply couldn't have continued giving out free courses or developing the technology. So if you want to help us keep the lights on, please buy a bootcamp. It's highly, highly appreciated. We're only 4 people, so we don't need millions of dollars to build this platform. However, we do need to pay our bills as well. So you can help us with that by clicking on one of these images, and then you're taken to the given bootcamp. Or with these two, you're taken to the waitlist page where you can add your email so that you'll be updated when the course launches, and you'll also be given the very best price. So go ahead and do that. We have a full 30-day money-back guarantee, so there's no risk in just trying one out. And I hope to see you in the chat room for any of these courses so that I personally as well can help you become a professional in the subject that you choose. Thank you. Hey there, this is Per from Scrimba, and I just wanted to let you know that we're working on a full-blown Vue JS Bootcamp these days. Meaning a course that aims to turn you into a professional Vue developer. It'll cover everything from the fundamentals all the way up to the advanced stuff that you need to know in order to build proper Vue applications. So in other words, in addition to learning about the core Vue library, it'll also teach you about how to handle data and update data in the application's state using Vuex. And also, of course, Vue Router to create single-page applications with multiple pages. Because these are core components for when you want to build real-world apps with Vue. And that's exactly what you're going to learn. It'll be massive, of course, over 10 hours of content. And along the way, it'll be filled with interactive challenges where you'll get your hands dirty with the code so that we make sure that the knowledge actually sticks with you. Now, if you're curious about this course, just click this link right here and you'll be taken to an email form where you can fill out your email so that you'll join the waitlist. And on the waitlist, you'll be assured that you get the very best price possible for this course, meaning you'll get it cheaper than anyone else, and you'll get exclusive sneak peeks as the course is created. So just click this link right here and take your first step towards becoming a professional Vue developer.
Hey everybody, and welcome back. In this episode, we're going to take a look at mapState. This is a helper that Vuex provides for us to create computed properties more efficiently. In the last episode, I showed you how to create a computed property. This is pretty simple, but would get tedious if we had to do it a lot. So I'm going to import mapState and show you how to use it. So mapState is going to replace this. Within mapState, we have a few different options for creating computed properties. The first is by using arrow functions. Pretty simple. We have some variable name, which is going to be accessible within our HTML, like so. We pass in state and return state.count. This is the same as we did in the last episode, just that the syntax is a little bit more succinct and will save you some time. The second option we have, and I'll create a count alias variable to store it, is by passing in a string. Once again, count alias is the variable that's going to be accessible within our HTML. And I'll change that here so we can see that it's working. Next, we have count. This refers to the state data member right here. Another situation you might come across is when you have a piece of local data that you want to combine in a computed property with your store data. So I'll create some local data here. I have local count, which is 4. And I'll make it a little bit more interesting by making count 3, just so that we can see something a little bit different. So to access both of these data members within a single computed property, we have to use a normal function and pass in state. State makes it so that we can access our store data members like we've been doing before in a couple of different ways, like with our arrow function or our original computed property. So to access our state variable, we're going to do what we were doing before by doing state.count. Next, to access a local variable, we're going to use the this keyword. It's going to be this.localCount. And now, count plus local state, which I'm copy and pasting, should return state.count, which is 3, plus this.localCount, 4. So it should return 7. I'll come and paste this into our HTML and refresh it. And good, it's working, and I can do math. Now notice that this shows us that not all of our state has to be held within our store. It's okay to have some data within our components, if they will only be used in that component. Use your best judgment. Vuex makes our code more explicit, but it can also be more verbose than necessary. Before we finish, I'm going to show you one final option, and I'm going to cut and paste this down here so you can still take a look at it. But this final option that we have is even more succinct and can be very handy. And that is by passing in an array of strings. The strings that we're going to be passing in are the names of our variables from our store. This is great for one reason in particular, because a lot of the times we're going to be using the same variable name within our application as we are within our store, like we have been doing with count. So instead of writing out an entire arrow function to do this, we just pass in this string. Now, if I change this back to count again and refresh, we'll see that it's 3 like it should be. In the next cast, we'll look at getters. This is another more advanced way to access state within our components. Hey everybody, and welcome to this episode. In the last few episodes, we looked at state and how to bring state into our application using computed properties. One situation that you might run across as you're doing this is that you will want to compute derived state based on store state. For example, I have a list of to-do items right here, and one thing we might want to do with them is grab all of the to-do items that have been completed. We could do this using computed properties, but we'd have to recreate that logic in any place it was needed. This would make our code more verbose and harder to maintain. Luckily, by using getters, which we'll be covering in this episode, we don't have to rewrite that computed property. I like to think of getters as computed properties for the store. the result is going to be cached based on its dependencies and will only reevaluate when one of those dependencies changes. So we create our getters within getters. I'll write the first one and explain to you what's going on. As a note before we keep going, if any of this JavaScript looks unfamiliar to you, I would highly recommend checking out our course here on Scrimba that covers JavaScript. It'll help you as you dive deeper into Vue.js and into Vuex. So to look at our getter, first we name it done to dos, and we pass in state. Getters always receive state as their first property, so we can access our data. Next, we filter through our array, which is state.todos, and we use this callback function to do that. So I'll log this to the console down below, and we should see our first to-do item because it has been completed. I'll bring up our console and run our application, and we see, like we should, our first to-do item. So this is a pretty powerful idea and will come in handy in many different places, but there's more we can do with it. For example, we can actually create a getter that depends on other getters. So I'll create one called done to dos count, and I'll pass in state like before, but I'm actually going to pass in getters as well. This will allow us to access any other getters that we've written. Here, I'm actually going to return getters.donetodos.length. Pretty simple operation, but it's cool to see that in this getter, we can actually grab this getter and, for example, find the length of it. I'll log this to the console down below, and we should see the number 1. And we do. Basically what's happening is the to-do items are being filtered by done to-dos and counted by done to-dos count, and eventually being displayed to the console. If we remember that Vuex is reactive, we'll know that if any of these to-do items change, done to-dos will reevaluate, and done to-dos count will also reevaluate. This is super awesome and will be great for our applications. The last getter type that we're going to talk about is what I like to call method style access getters. This allows us to pass arguments by returning a function. One use case for this is querying our store by ID. For example, I could search through our to-do items by their ID, and I'll show you how to do it in this example. So I name our getter getToDoById, and I pass in state like before. Like I mentioned though, we're going to pass in arguments by returning a function. So here, we're returning this function, and I'm going to pass in ID to it. And here, we're going to use the find method on our state.todos. And within find, the callback function that we're going to be using is going to search if the to-do item ID is equal to the ID that is being passed in like so. So going through this is super handy. We have a getter, we pass in state, and then we pass in any other arguments that we want, for example, an ID. And now we query our store, and in this case, our to-dos array, based on the ID that has been sent in. So for example, I can log to the console down here, and I'll pass in 2, and we should see our second to-do item. And awesome, that is working just like it should. I'll try it again with 1, and we'll see that it's also working. Maybe I'll try 48. And we do get null like we should, because there is no ID of that number. One thing that I forgot to mention is that we can access these getters using computed properties, just like we did in the last episode. So for example, if I want to grab done to dos count, I can name a computed property like that, and I can use this $store to grab it. And now I'm going to grab getters, and then the getter name, in this case done to dos count. And now I can use this computed property done to dos count within our application. I actually had a line here to show that. So this should display the completed to-dos and the done to-dos count getter. I'll bring up the browser, and it's showing the number 1, which is the number of to-do items that have been completed. So it's very helpful to realize that a lot of the same things that you learned in accessing state within our application is the same for accessing getters. You can use computed properties, and you actually have another helper you can use called mapGetters. I'll import it here. And we use this the exact same way. In this case, I'm going to pass in an array of strings so that we can grab all of our getters. Now we can use all of the getters that we have created within our application. This will definitely come in handy. Check out the next episode where we're going to start looking at how to change our data within the store. This is by using mutations, like we mentioned in the Getting Started video, and by actions. This will really make your Vuex application powerful. Hey everybody, and welcome to this episode on mutations. I've been looking forward to this episode for a while because now we're going to actually start making changes to our state. This will add a new level of interactivity to our applications. So mutations change state and track changes along the way. Like events, mutations have a type and a handler. The handler is what actually changes state. The type is how we commit a mutation. I'll show you an example here. In this case, increment is the type of our mutation and how we're going to call it. We pass in state so our data is accessible, and then here we have our handler. This handler is going to increment count by 1. I'm going to call this mutation and log the result to the console. Our store and application is set up like we've seen in the last few episodes, and then we run into this line, store.commit. This is how we commit or call a mutation, and we pass in the type of the mutation that we want to commit. So when our code sees this, it goes into the store and looks for the mutation with this type, and then it calls the handler of that mutation. And then I log to the console count, which should be 1 after running the code. And it is. This is awesome, but we can do more with it by passing in an additional argument. I'll create a second mutation called increment by, which will allow us to pass in an integer and increment count by that much. Like I said, we're passing in an additional argument n and incrementing count by that much. So if I came down here and changed this mutation type to increment by, and then I pass in the number 8, for example, count, which is 0 when we initially run our code, should increment by 8. And it does. This is great if we only have to pass in one argument, but normally we would want to pass in several different pieces of data. To do that, we need to pass in an object, which is generally called payload. For this example, our payload is going to have a property of amount, which is how much we're going to increment count by. So to call this, I would come down here and pass in an object with a property of amount and some value, say 29. And now, when I run our code, count should be 29. And it is. Optionally, you can commit a mutation by using an object with a type, like so. This does the exact same thing. I think it's more a matter of preference, whether you want to pass in an object with a type or you want to do it like we were doing originally. I'll run our code and see that this is running the exact same way. One thing to note before we move on, Vuex state is reactive, so when we mutate state, the Vue components will update automatically. This means mutations must follow one important rule of regular Vue reactivity. This is that we should initialize the stored state with all desired fields up front. So we shouldn't be creating properties whenever we can avoid it. When we have to, we have 2 different options, but both are less than ideal. The first is to use view.set. This will grab whatever object is in our store, and then it'll add a new property with this value. The second option that we have is using the spread operator. In this case, we're replacing some object within our state with the same properties it currently has, plus an additional property. Both of these situations are less than ideal, and it's very rare that you're going to run across a situation where you have to add additional properties. So just keep in mind that you want to create all of your data within your state up front. One last note, Vuex lets us use constants for mutations like in other Flux implementations. If you're coming from another Flux library like Redux and really enjoy using constants, check out the docs for more information. Now on to the most important part, committing mutations within our application. We can access a store like we have been doing with this $store, and then we can commit a mutation in any of the ways that were previously shown. I'm going to comment this out. So within our application's methods, I'm going to create a method that's going to commit a mutation. Whenever within our application we call this method increment, it's going to commit this mutation like we were seeing previously. I actually created a button within our HTML that's going to do that. I'll refresh the page so we can see it. And now when I click this button, this function or this method increment is being called, and in here it commits this mutation, which ultimately calls this handler. You might notice that this is a little bit like setting up computed properties to display our state. And that might make you think, like we've seen in the last few episodes, that there's a helper to let us do this more efficiently. And you're right, it's called mapMutations. mapMutations is going to replace the methods that we previously created. And we have the same options for creating methods as we did for creating computed properties. In this case, I'm going to pass in an array of strings. Now our application can make use of any of the mutations that we created. Remember, since we're using Scrimba, you can pause this video at any time, edit the code, and run it in the mini browser. I want to give you a small challenge. Pause the video now and add a mutation here to decrement count. Then create a button in the HTML that calls the corresponding method within your application. When you're done, you should have an additional button here that'll let you decrease count. Okay, hopefully that went well for you. In the next episode on actions, I'm going to show you the correct code in case you ran across any errors while setting that up. Before we move on, I want to give you one last rule, and that is that mutations must be synchronous. I'll give you an example. Imagine you're calling an asynchronous method within one of your mutations. For example, you're getting data from an API, and then you're incrementing count. Remember, for every mutation that is logged, the dev tool captures a before and after snapshot of state. However, the asynchronous callback in this example makes it impossible. The dev tool can't track when the mutation occurs and when the callback is actually called. This makes our mutation untrackable and is definitely not something that we want for our application. That would make debugging a nightmare if we run across an error. That's why we use actions for asynchronous methods, and we'll look more into that in the next episode. See you there. Hey everybody, and welcome to this episode. I wanted to take note of two things before we begin. One, I implemented the decrement button for our application. It's pretty simple, but if you wanted to check out the code to do that, you can pause the video. So returning to actions, actions are similar to mutations. They change our state. The difference is you dispatch an action, which in turn commits mutations. That might seem a little bit redundant until we remember that mutations must be synchronous. On the other hand, actions can contain asynchronous operations. So when we want to change state based off of some asynchronous call to a database or an API, for example, we would use an action to handle that. And whenever we get that information that we need, then we will commit a mutation. So I'll write a simple one and show you the syntax. Like a mutation, an action has a type and a handler. In this case, I named our action increment, and then I pass in context. Context is an object which exposes the same methods and properties of the store instance. For example, you can use context.commit to commit a mutation in the same way that you would use store.commit. You can also use context.state, context.getters, or additionally, you can call other actions using context.dispatch. You can use argument destructuring to simplify your code if you just need one type of method or property. In this case, we only need commit, so I'm going to use argument destructuring and pass in commit. Now that we've done that, I don't need to call context.commit, I just call commit. Now that we've seen the basic syntax of creating an action, I'm going to change this to be asynchronous and we're going to test it out. So whenever we dispatch this action, it's going to set a timeout of 1000 milliseconds or 1 second. And when that is finished, it'll commit this mutation. So I'm going to dispatch it here. So now when we click this button, it will dispatch increment async, which in turn commit increment. So let's refresh the page and see if it's working. Like we should see, there's a slight delay after I click the button and when count is incremented. Like I said, this is pretty similar to if we were calling a database or an API. We had some asynchronous operation, and when that was finished, we would want to commit a mutation. Two quick notes. You can also dispatch actions with a payload or like an object, the exact same way that we did with mutations. For example, if I had some payload that I wanted to pass in here, I could do it like that, the same way that I would with a mutation. We can also dispatch an action using an object. For example, I could say dispatch and then pass in an object. This is the same as we're using with mutations, so it's pretty consistent. And then the second note is that we also have a map actions helper. This will allow you to bring in your actions to your application much more simply, like we've been doing with mapState, map mutations, and map getters. Map actions works the exact same way. You can pass in an array of strings or an object that contains arrow function and key value pairs. Let's take a look at a few more ways that we can compose actions. So action A is going to return a promise. Then it's going to set a timeout to commit some mutation. It's going to wait a second before doing that. And when this asynchronous operation is finished, this promise is going to resolve. That means that down here, when I dispatch action A and it's accomplished, I can call then and then have a callback function within here. This will allow me to write some other code. Maybe I want to commit some other mutation or make some changes to my application. Whatever it might be, we can use promises within our actions. I'll write a second action that makes use of this. So action B does the exact same thing that we did down here with our test action. We're dispatching action A, and when this promise is resolved, then we will commit some other mutation. This lets us see that we can kind of chain our actions. Lastly, I'm going to look at two examples that use async and await. Okay, so these two examples, action C and action D, are asynchronous actions. In our first example, we're committing some mutation called getData, and we're passing in a payload. We're assuming that getData and also getOtherData return promises, so we're awaiting that call. This will wait to commit this mutation until we have getData. This is pretty important. We wouldn't want to commit the mutation before we had the payload. Our second example, action D, waits after dispatching action C for this to be finished. And then when that is done, it does the exact same thing. It's going to commit some mutation getOtherData with this payload, which also is returning a promise. Actions are very powerful, but a little bit more of a complicated subject. If you're having trouble with this, I would recommend going back, refreshing your memory with promises and a few other asynchronous topics. And then whenever you run across a situation where you're going to be needing to use asynchronous operations within your application, I would come back, rewatch this video, and you'll get some great ideas on how you can compose your own actions. In the next episode, we're going to take a look at modules. See you there. Hey everybody, welcome to this episode on modules. Because we have a single state tree, all of our state is within our store object. As our application begins to grow, the store can get quite bloated. Luckily, we can divide our store into modules. This will make our code much more structured and manageable. Each module, like these, contains its own state, mutations, getters, and actions. They can even contain their own modules. This really helps us break down our code and make it more reusable. Since I've created these two modules, I'll add them to our store like so. I name our first one A and pass in module A. This is the object we defined above. I do the same thing with module B. I'll log some state from each of these to the console. First, I'll add it. Now that module A, module B, and the store have count, I can log these to the console like so. We access store.state the same way, then we tell Vuex which module to look inside, and then we grab our count variable. I'll pull up our console and run this. We see 3 and 8 like we should. Now that we've looked at a simple example with state, let's look at mutations and getters. We've seen this mutation before. We define a type, pass in state, and have a handler. The getter is pretty similar as well. You might be wondering, when I have state, which state is it looking at? Is it the one within module A, module B, or within the store? In this situation, when we pass in state, it's referring to the local module state. So for example here, when I run increment, it's going to increment this count to be 4. The same goes for getters, as well as actions. I'll create a simple action so you can see that. Like before, when we create an action, we pass in context. I'm using argument destructuring. So when I have state, it's going to refer to this state.count. We can commit and dispatch actions very similarly to like we were doing before. I am going to commit our increment mutation so that we can see a.count increase. When I run this, a.count should be 3. It should increment by 1 and then log to the console as 4. and it does just that. This is pretty cool. We can break down our code like we've been doing. Notice that by default, actions, mutations, and getters inside modules are still registered under the global namespace. This is how we commit our mutation of type increment like we did. But notice there's a side effect here. If I was to have a mutation called increment within my store or within module B, those would also be called. So I could potentially call multiple actions, mutations, or getters with a single call. If you want your modules to be more self-contained or reusable, you can mark it as namespaced. I'm going to do that with module A. Now, when I call store.commit, we are actually not going to increment. And we see it's coming up as an error, unknown mutation type increment. That's because when I commit this mutation, it looks inside the store, doesn't see a mutation there. It doesn't look inside module A because it's namespaced, and we're not looking at that namespace. But it still looks inside module B, but nothing is defined there. If I wanted to commit this mutation, I would have to specify its path, like so. Basically, this is telling Vuex, look inside module A, and then find the mutation of type increment. And if I run it, it's working like it should. We can further nest our modules. I'm going to create a submodule in module B so we can look at that. We created our submodule within module B, and I'll create a sample mutation, getter, and action. I'll call it login to keep it simple. To commit this mutation, access this getter, or dispatch this action, we can do it like we normally would. I'll comment this out and show you that. You'll remember that module B is part of the global namespace because namespace is set to be false by default. This shows us that by default, submodules inherit the namespace of their parent modules. So in this case, submodule is also part of the global namespace. So when I commit login, dispatch login, or grab the getter called login, it's going to find these ones within our submodule. If I wanted to namespace module B, we would have to access them in a different way. Now that module B is no longer part of the global namespace, I will have to specify a path, like so. We access logins a little bit differently. We actually use bracket syntax like this. Now we're telling Vuex, I want to commit within module B the mutation of type login. Same goes for our action and our getter. We could further nest our submodule by namespacing it as well. Now to access these methods, I would have to specify the path again. Now you know how to nest modules, commit mutations, dispatch actions, and call getters from within any of those modules no matter how they're namespaced. This is very useful. Now we're going to look at a concept that is accessing global assets. When I refer to a global asset, I mean something that is within our store. So how can we grab some state from our store or commit a mutation here, grab this getter, or dispatch this action? I will create some sample methods within module B so we can look at that. So I set up some getter. We pass in state and getters like we normally would. This will allow us to access state and getters within the local module. In this case, that is module B. Optionally, we can pass in a third and fourth argument to get functions from root. Now within some getter, I can access root state like so, and our normal state like this. So root state.count is going to go within our store and find state.count, which is 2. Our regular state is going to look within our module, module B, and then it's going to find this count, which is 8. The same goes for getters. Getters.someotherGetter is going to look within our module B getters. Root getters, on the other hand, is going to look within the store getters to find that getter. We can do similar things with some action. Here I have context and I've used argument destructuring to gather a few different properties that we're going to need. I'll also get root getters. We do the same thing with getters and root getters. I'll show you how to dispatch an action from either our module or from our store. When I say dispatch some other action, it's going to look within our module. When I say dispatch in this way, it's going to look in our store. I pass in the action type, our payload, which in this case is null, and our third argument is this object which says root is true. This lets Vuex know to look inside the store. We do something similar with committing mutations. You'll see the syntax is the exact same, just that we're committing instead of dispatching. So we pass in the type of mutation that we're committing, the payload, and then we're saying root is true. Again, this lets Vuex know to look inside the store. Now we have a good idea of how we can structure our modules, create mutations, getters, and actions, and call other getters, actions, and mutations from within our local module or within the store. Now let's take a quick look at how we can access these different methods within our component. We're going to be using the helpers that we're already familiar with. In this episode, I'm going to take a look at mapState and mapActions for this example. I'm going to replace computed with mapState. And I'm going to show you how we could access count from our A module and from our B module. Pretty simple. We just have to nest or tell Vuex where we're going. For example, if I wanted to get some data member within submodule, which is in B, I could say b.submodule.count. This is how we're going to be nesting to grab our different state variables. Let's look at mapActions. I'm just going to use some sample names. Each of these are going to represent modules. I've specified the path. We're assuming that sum is a module within store, within that is nested, and within that is another module. Now that I'm at the path, I'm going to specify foo, which is the action. Within our application, we would access this using this and then in bracket notation. This isn't very neat. You can optionally pass the module namespace string as the first argument to these helpers. By doing so, you're binding this path to the helper. I'll show you an example to simplify this process. In this case, we're specifying that we want to map actions based off of this path. Now, instead of having to specify this entire path, I would just have to say foo. And then when I call it, I wouldn't have to say this dot everything that is in here. I would say this dot foo. This is a lot simpler. And by using object spread syntax, I can have several different map actions or several different map states, and the same goes for getters and mutations. Now that you have a good idea for how you can use modules to structure your code, we're going to take a look at plugins, form handling, and testing to finish up this Vuex series. Thank you. Hey, and welcome to this episode on form handling. As a quick note before we begin, I am going to enable strict mode in our store, like so. Strict mode is a useful function when we are developing our application. Strict mode runs a synchronous deep watcher on the state tree, which watches for any inappropriate mutations. Basically, it's checking to make sure we don't directly change our state from within our application. This can be quite taxing to our app's performance. This is why we do not use strict mode when building or deploying our application. It's just used for development. One error that we're going to run across when using strict mode and Vuex in general is form handling. Normally when we're using Vue, we're going to use a V model to bind some data member to an input field. In this case, I am V modeling message to whatever is in here. But we're going to run across a problem when I run this and try to make any changes. We'll see that the computed property message was assigned to, but it has no setter. Our application is basically saying, I have this computed property from the store and you want me to change it, but I can't do that. That's because vModel is trying to directly mutate the message from within our store. This will cause an error. There are two different ways that we can solve the problem. The first is to bind the input's value and call an action on input or change. I'll make those changes here in our HTML. Now whenever I change this input field, it's going to call the method updateMessage, and we're going to be able to access its value using message. I'll create a method here to handle that. Now when I change this input field, it's going to commit to the store a mutation of type updateMessage, and then it's going to pass in this value, which is message. I'll create that mutation here. I'm going to run our application again and see if it's working. So I'm going to delete that, and it's working the way it should. This solution is a bit more verbose than using vModel and local state. We also lose some useful vModel features. An alternative is using a two-way computed property with a setter. I'll update our computed property so that rather than just returning our message, it will get the message, but it will also set the message. Now our computed property has a method to handle getting message, but also setting message to some new value by committing this mutation. Now I'll return to our HTML and remove this with vModel. If I refresh this, we'll see that it's still working. This is pretty cool. We can use vModel with our Vuex application. Now you have a good idea of how you can handle forms by using Vuex. You can either use a computed property with two-way data binding by defining a getter and a setter, or on input or on change, you can call a method that updates the store. Now that you've seen both ways of handling form inputs, I want you to practice this with a couple of your own. Create a couple different input fields, maybe some text areas, checkboxes, or radio buttons, and vModel them to some data within our store. This will be really handy to practice that so that you're comfortable using this in your applications. Hey everybody, and welcome to this episode on plugins. Plugins is an option that exposes hooks for each mutation. A plugin is simply a function that receives the store as the only argument. These are super useful. You can find a lot of great plugins out there that other developers have shared. You'll also learn how to write your own plugins in this episode. I'll create a simple example to walk you through the syntax. So I define a plugin called myPlugin. I pass in store as the only argument. Then this is going to be called when the store is initialized. I have a method called store.subscribe. This subscribes the plugin to the store. Basically, anytime a mutation is called, the mutation will be passed into this function. The mutation comes in the format of an object, so it has type and payload. We add a plugin to our store, like so. Plugins cannot directly mutate state, similar to components. They can only commit mutations. By committing mutations, we could use a plugin to sync a data source to the store. I'll show you an example of syncing a WebSocket data source. This is just a contrived example, but it shows a bit more about plugins. So I'll comment this out and show you a second example. In this example, we have a function that creates a WebSocket plugin. Then we return our plugin, where store is the only argument like before. Then our socket on data is going to commit receive data and pass in that data. So whenever the socket receives new data, it's going to commit that to the store. Next, we have our subscribe method like before. We pass in a mutation, and here we're checking if the mutation is of type update data. So whenever update data is committed, this socket is going to emit update, and it's going to use the mutations payload. Like I mentioned before, mutations in this case are passed in as objects, so I can access the payload using mutation.payload. Sometimes you might want to have a snapshot of state before and after a mutation. This will let you compare any changes that have been made. This is really useful for debugging. To do this, we make a deep copy of state. I'll set up a third example to show you that. In this example, I create my plugin with snapshot where I pass in the store. I create a deep clone of our previous state. And then on store.subscribe, I save next state as another deep clone. Now I can compare state before and after the mutation. And then finally, I save state for the next mutation. Note, plugins that take snapshots should only be used during development. When using Webpack or Browserify, we can let our build tools handle that for us. So to handle this, I'm going to use some logic to decide whether or not to include this plugin, like so. In this example, we're checking if we are in production. If we're not in production, we're going to include the plugin with snapshot. If not, we are not going to include it. As a note, Webpack requires define plugin, and Browserify uses envify to convert our environment variable to false when building and deploying an app. Links to those can be found in the Vuex docs. Let's look at one final example of a built-in logger plugin. Note, if you're using DevTools, the Vue DevTools specifically, you probably don't need this, but it's handy to learn a little bit more about plugins. So Vuex comes with a logger plugin for debugging purposes. I'll comment this out so we can look at that final example. I did 3 things to set this up. I import create logger from Vuex, I set up a logger, and then I add it to our plugins. So the logger accepts a few different options. Let's walk through them. The first is collapsed. I'm going to set this to false. Collapsed is a Boolean and decides whether or not to auto-expand logged mutations. The next is filter. Filter returns true if a mutation should be logged. Note again that mutation is an object with type and payload. So in this case, we are logging every mutation except for any ones that are called a blacklisted mutation. The third option is a transformer. The transformer transforms the state before logging it. This doesn't actually make any changes to it, it just changes what we are displaying. For example, in this case, we are returning only a specific subtree to be logged. A fourth option is mutation transformer. By default, mutations are logged in the format of type payload, like the object that they are. We can format this in any way that we want. In this example, we are only returning the mutation type. And the final option is logger. This is the implementation of the console API, and by default is console. So hopefully with these various examples of plugins, you have a better idea of how you can leverage this tool in your next Vuex application. Practice around with it, and I would definitely recommend Googling and looking at different examples of plugins so you can see what other people are creating and what you might want to do for your own applications. Hey everybody, and welcome to this episode on testing. Testing in Vuex is a very valuable skill, and we will normally want to test our mutations and actions, but occasionally our getters as well. We'll be using Mocha and Chai in these examples. I've added them here using a CDN, and I've set them up. This simple setup is going to display our tests to the mini browser so that we can see those visually. I've created a simple store with some state and a mutation to start off. As a note, in a full build application, we would normally have our store within a file called store.js, and we would have our testing within its own separate folder. So to be able to pass off our mutations to our testing, we would have to use some named exports. I'll show you an example of what that would look like. So in this case, this would be my store.js, and at the end I would export my mutations. This would allow me to access within testing by importing them my different mutations. In this case, since we're in the same file, we don't need this, and so I'll comment that out. I'm going to create our first test, which is going to test our mutation increment. I've named our test mutations, and then the first one is increment. I'm directly committing to the store the mutation of type increment, and then I'm expecting count within the store to equal 1, because count starts at 0, is incremented, and then should equal 1. So if I bring up the browser, we see that this test has passed. This is pretty straightforward, and that's because mutations are basically functions. They rely directly on their input. So this is the exact same as what you would normally be doing when writing tests. Actions are a little bit more complicated. Generally, actions are asynchronous, and they also will most likely be having calls to an API. This requires a lot more mocking so that we can set up and kind of imitate that call to an API. So I'm actually just going to copy and paste a couple of examples of the mocking that would be required to test an action. So the first thing that I'm going to bring in is a copy of what our actions.javascript file would be. So this is importing the shop from the API shop. Because we don't have that, I'm going to comment that out. Then we would set up our action. This action is pretty simple. It's just committing a couple different mutations. So it's telling the store that it's requesting the products. And when it gets them from the shop, it's going to commit receive products and pass in those products. So just a fake little action, but it kind of shows an example of what we're going to be doing. Within our testing, we're going to use an injector to bring these in. More information can be found in the Vuex docs, but this is an example of what we'll be doing. So we call our action injector, which says require inject loader, and then it would go to our actions.javascript file, which ideally would be this. Then we create a module for our mocks. This is basically emulating the function of an API. Then this is the most important part. This helper called test action is being created. Within this helper, we're going to pass in the action that we want to test, any payload associated with that, the initial state that we're testing, and an array of expected mutations. These are the mutations that are going to be called within this action. And then we also pass in done. We start count to equal 0. This count is going to keep track of which mutations we have already called. To start out, we are committing a mutation of a certain type and payload. That mutation is going to be the expected mutations at whatever index we're currently at. So at first it's going to be 0, so the first mutation that was passed in. Then in this section, we're going to be testing if the mutation type is the expected mutation type. And then if a payload has been passed in, we're going to be testing that as well. If there's an error, it's going to throw that. After this test is completed, it's going to increment count. And then if we have reached the end of our expected mutations, we're going to call done. Finally, we're going to call the action with this mocked store and arguments. As just one last final check, if there are other mutations that have not yet been called. So this is a pretty long example, but it shows a very useful helper that you can use to test your actions. I'm going to comment this out, and then we're going to take a look at testing getters. Okay, in this example, I'm going to write a simple getter called filtered products. To emulate exporting, I am going to write it outside of our store. So I copy and pasted this in, and I have my const getters, which is an object. And then the first getter written within here is filtered products. It's going to go through our state, and depending on a filter category, is going to return any products that match that category. I'm going to scroll down here and create another test suite to work with this. I'll call it getters. Now to test this getter, I'm going to create a rule called it. And now I'm going to create a fake state to pass in. So this is one way that we can be testing our state. We can make a mock or fake state within our test. And then we can call that on some getter or action or mutation. So in this case, we're going to filter on the type fruit. So now that we're filtering on fruit, we're going to get our result by calling getters.filteredProducts. We're passing in this fake state and our filter category, which in this case is fruit. And we're expecting our result to equal a deep copy of this. So basically, we're assuming that we're going to return two objects that are both of type fruit. So if we run this and bring it up, we see that our getters test is also working. This is a very brief overview of testing within Vuex. Mutations are very straightforward, as are getters. We can pass in some mocked up state and then call them and compare them to whatever we are expecting to receive. But as you can see, testing actions requires a lot more setup and a lot more work. Hopefully this has given you a good idea of how you can use common JavaScript libraries like Mocha and Chai to test your Vuex applications.